Alright, so now you guys know what the molar mass is. It's unique to each element. Each element has its own unique molar mass. Here's kind of a picture of 1 mole of different substances. So this is the 1 mole of carbon atoms. It would be 12 grams. So if we were to measure out 12 grams of carbon, we're going to have 1 mole of it. And that goes back to Avogadro's number, 6.02 times 10 to the 23rd. Sulfur is a little bit lighter. So in order to have 1 mole of sulfur, we're going to be 32.1 grams. We're going to have 1 mole of mercury would be 200.6 grams. So if we measure 200.6 grams, we're going to have 1 mole of it. For iron, it's 55.8 grams, so they have their own unique. But with this picture, this is 1 mole. This is 1 mole, this is 1 mole, this is 1 mole. Each one of those samples has 6.02 times 10 to the 23rd atoms in it. So there's 6.02 times 10 to the 23rd carbon atoms. There's 6.02 times 10 to the 23rd sulfur atoms. You guys probably getting the idea here. So yeah, 1 mole, 6.02 times 10 to the 23rd. And they each have their own unique mass per mole, right? So carbon's 12, sulfur's 32.1, mercury's 200.6, 55.8. Those numbers are found on the periodic table, like it says right here. They're on the periodic table. It's that red number that you guys have. And you're going to round it to the nearest tenth. Actually, let's put this in the notes so you guys remember. Put a star by this. So round to the nearest tenth. So when you guys do your calculations, or you doing anything with the molar mass, take those values, round to the nearest tenth. All right. So then to calculate the molar mass of a compound, it's a little bit different. So far, we've just looked at molar masses of pure elements. This is pure carbon. This is pure sulfur, pure mercury, pure iron. You can just look at the periodic table. That's going to be the value. If we have a compound, we have to add up all of the individual molar masses. So for instance, if we have H2O, we're getting, if we have 1 mole of water molecules, we're going to have mass from the 2 hydrogens, and we're going to have mass from the 1 oxygen. So then to figure out the molar mass of the compound, we have to do it individually. If you look at the periodic table, the molar mass of hydrogen's 1. There is 2 of them. We're going to add that to the oxygen. The molar mass of oxygen, rounded to the nearest tenth, is 16. So then when you do the math, the molar mass of water is going to be 18 grams, and it's going to be grams per 1 mole, or grams per mole. So the molar mass of water is 18 grams per mole. So to give you guys an idea of this, if I were to take the mass of water, and if I have exactly 18 grams of water, that's going to be 1 mole, which is going to be that number, Avogadro's number, 6.02 times 10 to the 23rd. So this is how we do the molar mass of a compound. You guys are going to get really quick at this. The more you do, like you're going to see that hydrogen's 1, 2 times 1 is 2, plus oxygen 16 is 18. You're going to be able to do this with hardly even having to look at the periodic table. All right, so let me give you guys another example of this. We have sulfur trioxide. If we wanted to know the molar mass of sulfur trioxide, which is the whole molecule, we'd have to look at the individual components. We're going to have 1 sulfur atom and 3 oxygen atoms. All of these make up the mass of it. So then what you have to do is you have to consider, you have 3 oxygens, so that's where 16 plus 16 plus 16 comes into play. and then you got your 1 sulfur, which would be the 32.1. You add them all up, and you're going to get 80.1. If you notice, it's rounded to the nearest tenth. And that's how I would want you guys to enter it into Schoology. That way everybody gets the same answer. So round to the nearest tenth. Okay, let's try another one. We have the decomposition of hydrogen peroxide, H2O2. This is going to provide energy to launch a rocket. What is the molar mass of hydrogen peroxide? Okay, so when we write this down, it's pretty easy. You're just going to take, you have 2 hydrogens, the molar mass of each hydrogen is 1, and that's from your periodic table, that's the red number, plus you're going to have the 2 oxygens, and each oxygen is going to be 16. So then you're going to have 32 plus 2 gives us 34. So the molar mass is 34 grams per mole. 34 grams per mole. Let's see. So, to give you an idea, if I were to measure out 34 grams of this stuff, that's 1 mole of it. And 1 mole of hydrogen peroxide is going to be at 6.02 times 10 to the 23rd. Alright, let's keep working. Again, you guys are going to get really good at these molar mass calculations. And you're going to be able to do these in your head pretty much by the time you're all said and done. Alright, so we're going to find the molar mass of PCl3. Okay, you're going to look at your periodic table to find the molar mass. So phosphorus is molar mass, for example. I don't know if you can see this, but it would be 30.97. If we round it up, it ends up being 31. Plus, well, I could say 31.0. And then plus, we're going to have the 3 chlorides, or chlorines, and each one of those is going to be 35.5. So now we can figure out the molar mass. We're going to take the 31 plus 3 times 35.5, and I get, hold on, 31 plus 3 times 35.5, and I get 137.5 grams per mole. With sig figs, let's just go to the nearest tenth. I know there's 3 sig figs here, I know there's 3 sig figs here, but when we're calculating the molar mass, let's just always go to the nearest tenth. So that would be our answer right there. Maybe I should just say that. Molar mass is to the nearest tenth. Then that way everybody's consistent with our calculations. All right, let's try a couple more here. I'm going to show you how you're going to start to do these in your head. You're just going to have this stuff memorized. Like for instance, I have oxygen memorized. I know that's 16.0. I know hydrogen is 1. I'm getting better with potassium. I think it's 39, but I still got to look to double check. It is, I was close, 39.1. So then you just add it all up. So then the molar mass would be 56.1 grams per mole. So if I were to measure out, or take the mass of potassium hydroxide, if I had 56.1 grams of it, I would have 1 mole. All right, the next one, water. We've seen this one. You guys are going to get good at this. You have 2 waters, well, each hydrogen, or you have 2 hydrogens. Each hydrogen is 1, so 2 times 1 plus the 16. This one's just simply going to be 18.0 grams per mole. Okay, which brings us up to a challenge one. Iron acetate. Some of you guys are probably wondering what to do with that parentheses with the 3 on the outside. Well, it's kind of like math. You're essentially going to distribute it to each one of those, and you end up multiplying it. And I suppose I could write down the reason why is because that 3 is telling you have 3 acetate ions there. So you're going to have C2H6O3, C2H6O3, and C2H6O3. As you can see, if you were to break it apart and actually show it, it would be 3 times 2. How many carbons do you have? 6. 3 times 6. How many hydrogens do you have? 18. 3 times 3. How many oxygens do you have? 9. So that's why you end up distributing it. So I'm going to rewrite that down below here. I'm actually just going to write it as iron. And then I'm going to go C. I'm going to actually distribute it. 6. H18. And then 3 times 3 is 9, yeah. Okay. So then, you're going to look at your periodic table. You're going to find those red numbers. Iron is 55.8. You have 1 iron, so 55.8 from the iron. Plus, you have the carbon. I know carbon's 12. I have 6 of them, so 6 times 12 from the carbon. Plus, we have 18 of those hydrogens, so 18 times 1. Plus, we have 9 of those oxygens, and that's going to be the 16. So then you add all that up, and that is going to give you the molar mass of iron acetate. Plus 6 times 12 plus 18 plus 9 times 16. All right. So I get a molar mass of 289.8, and that's going to be grams per mole. And again, we rounded it to the nearest tenth. So that is the molar mass of iron acetate. If we wanted 1 mole of this, we would have to measure out 289.8 grams. Then we would have 1 mole of that compound. All right. So this is just kind of showing you some different molar masses. Yeah, glucose is here. That's 180 grams per mole. Water's here. You know it to be 18 grams per mole. This is actually mothballs. That would be 147 grams per mole. And then there's some quiz questions. We can kind of go over these. 3 common ways of measuring the amount of something are by count, by mass, and by, what does Connor think? Because he's around.
Connor's studying for the test today.
Oh, he is?
Yeah.
Well, you were going to say volume, right?
Yeah.
All right, good deal. All right. A mole of hydrogen gas contains 6.02 times 10 to the 23rd. Is it going to be molecules, atoms, AMU, or grams? A mole of hydrogen gas. So that's that whole thing. That's actually the hint. That's that H2. So is it molecules, atoms, AMU, or grams? And I know Connor wasn't here yesterday. It's going to be molecules. All right. So the atomic mass of fluorine is 19. So the molar mass is, that's 19 grams. Okay, next one. Calculate the molar mass of ammonium nitrate. I'm going to let you guys do this one on your own. I'll show you the formula. NH4, because that's ammonium with a +1. Nitrate is a -1. So you're going to have NO3. And I'll let you guys figure that one out on your own. Okay. Oh, there it is. End of show.